the people here are pretty well informed about what OsmoSDR is, and I think mostly even what the status is. So I'm just going to give a quick update, and then we can make some more discussion or answer questions or something. So the project has been running, maybe just to indicate, it has been running a bit different than some of the other projects that we do inside the OsmoCom project, or under the OsmoCom umbrella. That's primarily because the people who are doing the hardware and the FPGA design, they wanted to do that anyway, since they needed it for some amateur radio projects. So that was the main motivation for them to do it, and then they said, okay, yeah, this is nothing that we want to earn money with anyway, we can also release it as open source hardware and release the VHDL code and so on. And I said, yes, of course, then I can work a bit on the firmware. I wanted to use the SAM3U anyway and write some code for that. That's sort of how we got together in this project. So this maybe explains why things are running a bit different than with other projects. So the status of the hardware is that finally the PCBs have been ordered. So the final design has been sent to the PCB maker, and component placement, PCB assembly should happen within the next 3 weeks. There may be slight delays, of course. It's even for the component placement and manufacturing is not the highest priority project, so if there's some other schedule issues, then maybe it gets delayed a bit more, but I would expect it to be assembled in the next 3 weeks. All the components have been on stock for quite some time, with the exception of the LNA, which was added recently in the input. So components for 100 units have been in stock for multiple months, because originally the schedule was planned a bit different. Yeah, as I guess everyone knows by now, the sample rate will be about 1 megasamples, maybe 1.2 megasamples. We cannot do more in the hardware design that we decided on right now. Now we could have postponed it further and made a lot of changes to the hardware, but then the guy who was doing the hardware design, he's very happy with 1 megabit, and it was what we were aiming for initially. So the motivation of redoing the entire hardware design and delaying the project further to higher sample rates was not really something that anyone felt compelled to do at this point. I mean, this doesn't mean that a second revision couldn't be better, but at least we'll build those 100 units now in that design, and there can always be improvements later on.
Just a quick question, what is the actual limiting factor? The
limiting factor is the maximum clock or signal rate on GPIO lines of the SAM3U. So we're using a single wire synchronous serial interface between the FPGA and the SAM3U. So the Atman has an integrated peripheral called SSC. I think it's a synchronous serial controller. And all the GPIOs on the SAM3U, they have a maximum, what was it? The maximum speed, I think 35 megahertz or something like that, maximum speed of signal changes on any GPIO line.
Now I remember the discussion, yeah.
Yeah, so that's basically the limiting factor. Of course, we could have a different interface between the FPGA and the SAM3U, but all of them would involve quite a number of lines in parallel. That means significant PCB rerouting and so on. So we just said, well, let's do it this way now. Yeah, the software, as I guess you know, right now we are doing a USB audio device at 1 megasample, which is well within the specification, and it works on Linux. Apparently it doesn't on macOS and Windows. So we have to have custom drivers on those systems, but at least for now we are using that USB audio device. But I mean, there can be multiple firmware images, or even multiple modes or multiple configurations on the USB device. We have a lot of flexibility there. Yeah, that's sort of the current situation. The spectrum looked relatively clean now. I think it was a 30 megahertz signal at some point. I mean, a little bit of leakage from the local 30 megahertz clock into the spectrum, but otherwise it looked fine from the RF measurements that have been made and that have been taken. Any questions or discussion? I know that well, in terms of controlling it, my idea was to implement the SAM3U has a lot of endpoints, USB endpoints, so we can have a virtual serial port in parallel to the USB audio device. So my idea was to implement the CDC ACM serial port and then have actually a protocol that can be entered by humans as well as machines on the serial port for configuration, like tuning to a certain frequency, where you could just open a terminal port and you can say, well, tune a frec equals whatever, enter, and then it will tune to that frequency, which is something that you can relatively easily generate both from a software that runs on the PC as well as you can do manually. Now there has been some controversies around that. I think Peter wanted to have a binary protocol. He doesn't like USB serial ports. I told him, well, if you write, sorry?
I want an AT interface. I know you like it, AT.
AT commands, yes. Well, I mean, the USB serial port, we can have AT commands in there.
I know people will like it.
Yes. AT plus SDR plus CFREC equals.
You might have like two control interfaces. As you mentioned, there may be many endpoints. So one for binary control and one for.
Yeah, that may be. I mean, the control interface doesn't need high bandwidth anyway. So a binary control interface could use even the control endpoint of USB using a vendor or class-specific non-standard control transfers, which I think libUSB allows on any supported platform. Just to send an arbitrary binary request on the control pipe of a USB device. So we wouldn't even need an additional endpoint for just some control messages back and forth. One thing that also is pending that hasn't been done is the timestamping of samples. That, of course, I mean, in USB audio we cannot do timestamping because anything that gets transmitted in the isochronous pipe is sample data. We cannot have a header that indicates some frame number or something. It's not possible. But if in a mode that is not USB audio, in a non-USB audio interface, we could of course add timestamping information, which would help the host PC software to notice if there have been lost bytes or lost frames, and we don't lose sync in such situations. It should be possible easily because the SAM3U can just get together DMA, so we don't have to copy any data or something. We can just, when we send the USB, we set up the DMA for the USB in endpoint. We can say here is a chunk with so many bytes, and there is another chunk with so many bytes, and it will do the DMA transfer with chain descriptors. It's not a big deal technically to do that. Okay, questions? Yeah, the price I think has also been mentioned before. It will be 150 euros plus tax. That's 180 including German VAT and 150 for everyone who doesn't need to pay that. We cannot really make it cheaper. It's not that we, as I said, none of the people involved are doing this for money. But there's a component cost. The SI 570 that we use is not a particularly cheap hardware clock generator. I think that alone probably accounts for $20–30. Then there is the SAM3U, there is the E4000, which is also not sourced as cheap as probably it could be sourced, as we found out now. The PCB, the placement, we have to have, since it's sold as a product, we have to do all the electronics waste registration according to German or European waste electronics waste law, the WEEE, and all kinds of other things. So it's, I just want to make sure you understand this is, I guess for all the stuff that we put in the shop, there's not much money we earn on this. It's really a service to the community and not something. I mean, OsmoCon doesn't earn money really in any significant way from that activity.
And it's still open hardware, so you can take the layouts and do it yourself. There's a BGA.
There's a BGA. Well, yes, there's a BGA there, but it's even if you do it yourself, I would be surprised if you get to a cheaper price. I mean, that's we cannot compete with the RTL SDR, of course, in terms of price. Which, by the way, we have ordered 100 now from China, so they will also be in the web shop in 2-3 weeks.
Related it to OsmoSDR?
No. But really, we have managed to get a very good price on those. And but the price is not primarily the reason for ordering them. It's really the availability in Germany, because the number of people who cannot or for whatever reason do not want to go through the hassle of ordering stuff from China, and it's always good to have a local source. Okay, questions or comments or?
Is the transmission port prepared because there's the header, or?
Yes. Yes. So that both from the FPGA as well as from the SAM3, there are a significant number of I/O pins and SPI and SSC again on the headers. So a transmit board will be developed in the coming months to be put on there. And it's sure that it will happen, because that, as I said, Stefan, the guy who's doing the hardware design, he is doing this for an amateur radio, I think for a relay station that he needs to build anyway. So he himself has a strong motivation of implementing the transmit board, and it's not that we need to push somebody or something like that. So it will happen. And it was, I don't think Stefan was ever the one who was slowing down the project anyway. It was mostly, well, there was some hardware bug that needed some time to resolve, and then I didn't have time for the firmware, and then the guy who wrote the VHDL code also didn't have a lot of time, so it was sort of finding time at the right point in time to coordinate the different parts coming together.
So, what is the resolution of the ADC?
It's a 14-bit ADC.
14 bits.
Yes, and the ADC itself can do up to 4.2 megabits, megasamples, but we only use it up to 1.25 or something.
Okay. And do you have any analog filtering?
The E4000 has a lot of filters built in and various stages that you can configure, software configure. Also the driver for that is implemented, and there is a header by which you can actually plug different additional analog filters into the design.
And so this is IF filters?
Yes. This is IF, yeah.
Okay.
Well, it's zero IF, so baseband filter.
Yeah, no, yeah, I mean, it's still IF filter. Okay. So, and what is the bandwidth of those filters which are built in?
The lowest one, I think, is about, what was the lowest one? Somewhere between 0.5 megahertz and 1 megahertz. Somewhere in there.
How many megahertz?
I think it's higher than, does somebody remember?
Yeah, I'm always confusing the LFS filters.
Yes. No, they are typically very wide banded filters. So the lowest, I think we will run the lowest one almost all the time, because the chip is intended for digital TV reception, and there you have like 7-8 megahertz wide channels and not small narrow band channels. So that's. But what we could actually do, of course, is to run with oversampling and then do some simple digital filtering in the FPGA as well.
Yeah.
Since we have 4.2 megasamples, we could take a wider part and then do some sample. It's not a very powerful FPGA, but I think Sylvain did some calculations and
Yeah, it's totally, you can fully run filters.
yeah.
Yeah, and so you mentioned that there is a connector for external filter. Is it routed to some really external connector on the board?
Yes, it's a 2.5 millimeter header actually. It's differential I and Q, and they both go onto a 2.5 millimeter regular. I can show you the board.
Like the double connector on the TRX3.
What?
Like the double connector on the TRX, so standard 2 connector.
So when you no filter connected, you just connect the IF.
You put jumpers instead of a filter right now. So you see the jumpers here.
No noise.
That's where the I and Q gets jumped right now without a filter.
I look at his numerics and right.
There's also a picture online, so if you go to the webpage, you can also see a high-res picture. So we maybe Holger, can you open the SDR.OsmoCon'12 on the screen, and everyone can see it. Hardware, yeah, the hardware page. Is it touch sensitive?
Sure.
There should be a picture somewhere.
I think on the start page.
I think it was
Right,
yeah.
right
it was
on
the start page.
Yes.
Okay. Well, yeah, we have to enlarge that. Here you can see the jumpers here. So this is I differential and Q differential, and here you can see the traces go into the ADC.
The middle ones are ground or is?
Ground and VCC will get
It's ground and VCC. Yeah.
Yeah. This is the fifth jumper for generating.
Yeah. Well, but there is a current limit in it, so it shouldn't damage anything. It's one of these fuses that reset itself. It's actually those large things here. I mean, that was the first thing when I saw the hardware. Why do you put these through-hole capacitors on the board? They will just break after some time mechanically. It's not capacitors, these are... Sorry?
Poly switch.
It's the poly switches, exactly. And so this one is for the phantom power for the antenna, if you have an external LNA. So if the LNA gets short-circuited or your coaxial wire gets short-circuited, that will interrupt the circuit. And there's another one on the USB power input over there, which does the same if you overpower the short circuit on the board. So those are actually not capacitors.
But why is it not SMD in true?
Because allegedly you cannot get parts with the parameters they need in SMD casing. I think Milos disagreed, but I didn't want to get involved in that discussion. So, I mean, Stefan, who built that hardware, he builds DVB-T and DVB-S transmitters and all kinds of very high-end, sophisticated RF stuff. And if he thinks this is the way to go, then I'm not going to argue with him.
Also, they looked at the stuff they had in stock already for their other products.
Of course.
So, yeah.
Yeah, of course, they try to reuse a lot of the parts. It's also why we have some of the things on the board. Like the SI570, in this particular, it has this parts available in lots of configurations. And this one is not particularly suitable for what we do, but they have it in stock, and it's a part where that it's always custom order anyway. And if you need to order 100 of them in a custom different configuration, it's going to be even more expensive than before. These headers here, they will change to sockets, because you will use the RX port alone quite often, but you will never use the TX port alone. And these you bend them very easily, these pins. So that's why we decided in the final run we will put female sockets on this board, which they don't bend so easily or break so easily. And the transmit board will have the male connector. Yeah, sorry for the bad quality picture. It's visible nonetheless. Okay. Well, I mean, the VHDL is not in a public repository yet, but if you want to have access to the VHDL, you can send me your SSH key, or if your SSH key is already on the Git repository, let me know. There's nothing secret in there, it's just the guy who wrote it wants to clean it up further before it becomes publicly released. So, yeah, the firmware is in a Git repository. I'm using Cortex M3 toolchain for it. You cannot use the same that we use for the Calypso, because Calypso is ARM7 TDMI, and that one is a Cortex M3 with thumb2 instruction set. So we need a separate toolchain for that, but otherwise feel free to contribute. The host program doesn't exist because configuration is done over, right now it's still the physical serial port that you enter the commands on, which will become the virtual serial port. As said, the data is just USB audio, so you don't need a host program. You can use a record or something like that for recording ELSA from ELSA sources.
The patched A record with the high sample rate. I think A record is the one that complains.
Yeah, but
90,000.
yes. I think you need a one-line patch in a record, because in the entire ELSA subsystem and all the drivers and the libraries, nobody cares about the sample rate, but a record has an arbitrary limit of 200,000 or something like that. It refuses to accept a sample rate above 200,000.
The actual people, one maybe for some people interesting SDR component is a video grabber card from the BT whatever 700 chipset. Because actually this has an audio ADC, which is actually with the parameters of the video ADC, so you can clock it at 2 megasamples a second. It's only one mono channel, but might be sufficient for some stuff.
Yeah, BT 878. Okay, good. Then if there's no further.
Yeah, and this has the same problem with the audio sample rate.